A Latin square is an array with n number of columns, rows, and symbols. The symbols in a Latin square can be of any form. The symbols in the following examples are letters starting at A. Something interesting to note is that all of the following Latin squares are in reduced form. This means that the first row and first column are in order, designated by the alphabet. Latin squares can exist in non-reduced form as long as a column or row does not share the same value more than once. Latin squares contain three different data parameters. These are designated below by the rows, columns, and symbols. When using a Latin square to organize data, it is important to have three separate data types. When assigning data to columns, rows, or symbols, it is important to think about what your data represents and how you want to display that data. In general, it makes sense for the symbols to represent the data you are most interested in. The columns and rows are then reserved for the data that affects your subject represented by the symbols. For example, if you are testing the strength of a beam using different materials and beam sizes, it would make sense to have the symbols in your Latin square represent differing materials, while length and width are represented using the columns and rows. This is an example of a Latin square design from an experimental perspective. In this experiment, a ball of certain radius and material is bounced on a surface of varying material to determine the ball with the highest bounce. The difference in material is my primary concern in the experiment and is assigned to the symbols on the Latin square. The columns in the square are designated with the radius of the ball, and the rows in the square are designated with the surface material type. The data shown is only for example. This is not a real conducted experiment. Looking at the highlighted value, we can see that a ball with radius 2, surface 3, and material D bounced with a height of 5 meters. If we take a look at column 1 and row 1 of this specific Latin square example, we can see a trend. Across row 1, we notice that the height of the ball increments by 1 meter as we increase the radius. If we look at column 1, we can see that the height of the ball bounce increases by 2 meters as we increment from surface 1 to surface 4. From these observations, we can tell that the radius affects the height of the ball bounce less than the differing types of surface area. This is not everything you need to know about Latin squares, but it gets you started. There are many different ways to interpret Latin squares and use them in different experiments.